So how can we prevent this accidental mutation here? We need to use immutable objects. So earlier in the section about change detection, I introduced you to Immutable.js library. If you haven't watched that lecture, be sure to watch it before taking this lecture. So in the terminal, npm install immutable save. All right, now let's go to the app module. So this is the initial state of our store, which is a plain JavaScript object. We want to convert this to an immutable object. So on the top, I'm going to import from JS and map from immutable module. Now back here, I'm going to call from JS here. So this function gets a plain JavaScript object and returns an immutable object, which is of type map. Now we also have a map function, which does the same thing. However, if our object has properties that are complex types, from JS will apply immutability on those sub-properties as well. So here we get an immutable object, which is of type map. And with this, we need to change this constructor so our state is no longer an instance of IAppState. It's a map of string and any. This map is a generic type. It takes two generic parameters, key and value. Our properties are always strings, and our values can be anything. That's why we have a map of string and any. Now here we have a compilation error. Because our root reducer is working with instances of IAppState. So we need to make the same change here. We need to replace IAppState with map. So on the top, import map from immutable. Now we change this to map of string and any. And it should also return a map of string and any. With this, we can prevent accidental mutations because our map object does not have a counter property. In fact, the properties we store there are not accessible using the dot notation. So, delete. And now when working with immutable objects, we don't need tassign anymore. So you need to choose between using the tassign approach or immutable objects. They both have strengths and weaknesses that you will learn by the end of this lecture. So, delete this line. Here, we return state. We call the set method to modify the counter property. And for the value, first we're going to get this property and then increment it by 1. So this set method always returns a new object. It keeps the original state unmodified. And finally, let's go to app component. Once again, on the top, we need to import map from immutable module. We need to change this constructor here. So we get a map of string and any. And the final change. We use this select decorator to select the counter property of our state as an observable. But you know that we cannot access the counter property like this. We need to use the get method. So get like this. Now, if you look at the documentation for the select decorator, they claim that it does have support for immutable objects from immutable library, but it hasn't worked for me personally. And the example they have on their documentation is not exactly the case we're dealing with here. I look at their source code, I look at their test cases. There was no test case for working with immutable objects. So I have this feeling it's not implemented properly. So at the time of recording this video, the only way we can select a property from the store is by using an arrow function. So s as the state goes to s.get counter. So these are the changes we had to make to work with immutable objects. Now let's quickly test the application. Beautiful. So with immutable objects, we prevent accidental mutations. However, our code is a bit more verbose. So look, everywhere we had IAppState, now we have to use map of string and any. Also, we cannot access properties using the dot notation. So we have to use this get and set method. We have to work with these magic strings. And if we make a typo, our code doesn't work. And finally, this interface here becomes useless. Because here in the reducer, I can call state.set and add a property that we have not defined in our interface. Is online, set it to true. That's perfectly valid. So on one side, we gain something, but we lose a few other things. And at the time of recording this video, I personally prefer the T-assign approach that I showed you in the last lecture. But if you see value in using immutable objects, that's perfectly fine. You can use it in your project. Either way, you still need to write unit tests to make sure your reducers are implemented properly.